In the last classes, we studied about how to apply KVL for two loop method or mesh analysis, how to do for two loop. Now we go for three loops. How many loops we consider? Find the loop currents by using loop analysis or mesh analysis for this circuit. A circuit consisting of 100-volt source and another one 40 volts and 5 resistances. Totally we found three loops. The loop 1 I1 current flowing, loop 2 I2 current flowing, loop 3 I3 is current flowing in this. Now apply the KVL. While applying KVL, what we assumed, the current direction, according to current direction, we are given the polarity for this. The current is entering at V1, voltage source 100 volts is positive side, it is leaving. Positive side it is leaving. Now assuming positive side when it leaves, when current or when higher rise in potential, when rise in potential we have to consider rise in potential, we have to consider positive. Similarly, when current is moving in this direction, you can assume in this direction. When current is moving in this direction, positive current will leave. That means 100 volts will be considered as positive minus. According to KVL, what is KVL? Summation V equal to 0. That is V1, V2, assume that 8 ohm is V1 or V2. V1 is the voltage source and another one V2 is 8 ohms is the voltage across 8 ohm resistance or voltage drop across 8 ohm V2. The total voltage drops are equal to 0 in any loop. That is KVL. Now we are applying loop 1 KVL. Summation V equal to 0 or V1 plus V2 plus V3 equal to 0. But according to the direction of current, rise in potential is there 100 volts. 100 will be considered as positive. But what is the V? V equal to IR according to Ohm's law. Now V2 can be written as I into R, I1 into 8, but fall in potential it is 8 ohm. Fall in potential, that means current is entering at positive, leaving at negative. All resistances will be considered as negative. Minus 8 I1 minus 10 I1 minus I2. I1 minus I2. Assume that in this loop current is I2. Current entering in this loop is, our current is I1. Bigger current we have to assume. Our current is bigger, assuming that I1 minus I2. Current through 10 ohms resistance is I1 minus I2. Similarly, when you apply that KVL for loop 2, we are getting this equation. From this equation, this is the equation 1. After solving this, 10 minus 8I1 minus 10I1. We are solving this equation. Finally, we got this equation 1. This is the equation 1. Now, the key points are rise in potential, we have to assume positive, negative, fall in potential. Applying KVL for loop 2. This loop we are applying KVL. For this loop 2. This loop 2 we are applying KVL. Now, for this there is no voltage source, but all our resistances all will be considered as negative because current is moving in positive, entering positive, negative is leaving. That is fall in potential, that is minus 10 I2. The current entering through this resistance is minus 10 I2 because voltage drop across this is V equal to IR formula we are using. I is the I2 and R is the 10 ohm that we are using. V equal to IR. Ohm's law we are applying. After that, current entering to the 10 ohms resistance. 10 ohms resistance, but 10 ohm is another current entering, I3, that is I2 minus I3 minus 10 I2 minus I1 equal to 0. After solving this, you can get 10 I1 minus 30 I2 plus 10 I3 equal to 0, that is equation 2. Similarly, we are applying KVL for loop 3. If you apply KVL for loop 3 have one voltage source. Loop 3 have one voltage source, 4 I3 minus 40. The current is leaving at negative, that means fall in potential, that will be considered as minus 40 plus 10, that is I3 our current, another current that is common branch, it is for I2 also, then I3 minus I2. From this equation we got equation 3. This is the equation 3. 3 equations should be right in matrix form. After that we can solve. After writing the equations 1, 2, 3 in matrix form, that is 18, minus 10, 0, this coefficients we are writing I1, I2, I3 coefficients plus 0, I3. In the first equation there is no I3 current, hence we assumed as 0. After that minus 10, minus 30, 10, 0, minus 10, 14. That is coefficients matrix. It is another one is I1, I2. After that it is constant matrix. From that we found first delta is calculated for this matrix. After that delta 1 to calculate delta 1, what we have to do, these constants will be replaced in this column. That is delta 1 is equal to 100, 0, 40, minus 10. Remaining two columns will be same. For this we determined that it is minus 36,000 delta 1 is. Similarly we calculated delta 2. How to calculate delta 2? We have to replace the constant matrix with column 2. In the here we have to replace this, and remaining two columns will be considered. That is minus 21,200. Similarly delta 3. Finally we got I1, I2, I3. These are the currents in various branches, various loops we can calculate. Now I1 is 8.25 amps I calculated. I1 is calculated from delta 1 by delta, I2 is from delta 2 by delta, I3 is from delta 3 by delta. Finally we got the answer. I1 is 8.25 amperes. If you substitute I1, you can calculate the current through any branches. Suppose 8.23 amps is flowing in I1. I1 we calculated as 8.25. Similarly we can calculate I1 minus I2, current through 10 ohms resistance is I1 minus I2. Like that we can calculate so many branches. Find the loop currents only, they asked the question, hence loop currents we calculated. Like this we are applying 3 by 3 matrix. How to apply 3 by 3 matrix? How to obtain 3 by 3 matrix? That by 3 equations. After that we calculating I1, I2, I3. This is the method of doing KVL or mesh analysis for 3 by 3 matrix or 3 loop method.